XV-3, an advanced new type of aircraft, takes off and lands vertically as a helicopter and flies at high forward speed as an airplane. This versatile fixed-wing craft is the product of thorough development, including more than 400 hours of ground and flight testing. Except for its large convertible prop rotors, this unique aircraft is constructed as a conventional airplane. The 23-foot diameter prop rotors provide efficient vertical lift at low speeds and forward propulsion at high speeds. The engine is centrally located in the fuselage with power transmitted to the prop rotors by drive shafts inside the wing. A scoop-type intake admits engine cooling air. The skid landing gear has 4 small solid wheels mounted inside the skids for rolling takeoffs. Single-axis swash plates introduce cyclic and collective control to the two-bladed, semi-rigid prop rotors. The hub assembly, uncovered on this experimental model, will be enclosed in a streamlined spinner on production versions. The slip ring transmits test data to recording oscillographs. 2 conveniently located doors provide easy access to the pilot and co-pilot stations. The XV-3 is designed to U.S. military specifications and load factors throughout. Provisions are made for litter loading through special long cabin doors. Early in the joint U.S. Army-U.S. Air Force program, a quarter-scale powered model was put through a thorough series of wind tunnel tests at Wright Air Development Center. These tests demonstrated feasibility of the conversion process and defined performance and stability characteristics. Continuous conversions in both directions, numerous runs at intermediate mast angles, and propulsive efficiency tests at both high and low rotational speeds and air speeds up to 200 knots were successfully accomplished. These tests provided valuable design data and confirmed the soundness of the basic configuration. Full-scale whirl tests verified drive and control installations. In the full-scale wind tunnel at Ames Research Center of NASA, the XV-3 completed 2 extensive series of tests covering all flight regimes. Data obtained were used to define the stability, performance, and control characteristics of the actual aircraft and to prove the dynamic stability of the two-bladed prop rotors under simulated free-flight conditions. Tests were conducted to a speed of 160 knots. Following preliminary tests, an extensive contractor flight test program was conducted. Here, a normal engine start is followed by cockpit check of controls and instruments. The pilot increases blade pitch and power to make a normal vertical takeoff. Hovering characteristics and control are similar to those of a helicopter. Hovering stability improves as height above ground is increased. Good controllability is demonstrated in a 360-degree hovering turn. The XV-3 is capable of performing all helicopter maneuvers, including rearward flight. The XV-3 may be flown with its masts in the vertical position at all airspeeds up to 100 knots. Climb out is made with about 15 degrees mast angle setting to 5,000 feet altitude for initial conversion tests. The initial conversion tests shown here in slow motion were made in steps, allowing flight characteristics to be checked at several intermediate points. This first full conversion to airplane flight indicated excellent airplane stability and control characteristics. This view shows the XV-3 as it appears in flight at normal camera speed and high prop rotor RPM. Reconversion from airplane flight can be made in steps or continuously over a wide range of airspeeds and engine power settings. On normal VTOL missions, a helicopter-type approach and landing are made. One advantage of the low disk loading of the XV-3 is indicated by the absence of blowing dust and debris during the latter part of its approach over an unprepared area. This aircraft configuration affords agility and maneuverability for operation into and out of confined areas that is unmatched by any other VTOL aircraft type. As shown here, rearward and sideward flight are easily accomplished. With wheels installed, short takeoff characteristics were evaluated briefly at Bell. With masts vertical, the nose pitches down at liftoff, but the short roll permits the XV-3 to take off with about twice its hovering payload. Using about 20 degrees of disk inclination improves acceleration and results in a level attitude at liftoff. On completion of contractor flight tests, the XV-3 went to Edwards Air Force Base for evaluation by the Air Force Flight Test Center. Here, Major Robert Ferry, Air Force project pilot, prepares to take off for a typical one-hour test flight. Rolling takeoffs and landings during most of the Air Force program permitted greater fuel and instrumentation loads. Climb performance was measured over the complete range of mast angles up to 45 degrees. An angle of 30 degrees was found to be optimum, with a maximum rate of climb of over 1,500 feet per minute. This is nearly double the rate obtained with masts vertical. Airplane characteristics in steady and maneuvering flight at both high and low prop rotor rotational speeds were investigated. This maneuver is being performed at low RPM, which is provided by the two-speed transmission for high propulsive efficiency in cruise flight. The XV-3 is one of the few VTOL aircraft types that is capable of making safe descents and landings after complete power failure, using auto-rotation like a helicopter as shown here. Rolling landings utilizing the small wheels mounted inside the skid are often used following test flights. Although there is no braking system, rapid deceleration is accomplished easily by applying aft cyclic control. The XV-3 was flown to Bakersfield, California for special Air Force tests of its short takeoff and landing performance. These were conducted at several mast angles. Preliminary tests included a full auto-rotation landing. A typical takeoff uses a short ground roll, liftoff, and acceleration to 30 knots at low altitude, and a steep climb-out to clear the imaginary 50-foot-high obstacle. Large rubber wheels were used to improve ground roll. Here, a steep approach followed by a landing on an unused taxi strip covered with layers of dust and gravel again demonstrates the advantages of low disk loading in field-type operations. Distances to clear a 50-foot obstacle were recorded using a Fairchild camera on a previously surveyed course. With STOL tests completed, the XV-3 heads back to Edwards with a low-altitude pass in airplane configuration. During the flight over the mountains between Edwards and Bakersfield, the first cross-country flight to be made by any VTOL aircraft, conversion and maneuvering characteristics were checked in detail. In spite of gusty air over the mountains, as indicated by disturbances to the photographic airplane, the XV-3 successfully completed severe maneuvers in airplane flight, as well as at intermediate conversion angles, as shown here. This unique ability to operate over a wide airspeed and mast angle range with excellent stability and control gives the pilot desirable flexibility in the performance of a military mission where his attention may be diverted during critical phases of the approach to an objective. On the XV-3 type, the absence of auxiliary control or propulsion units that are used only in one flight condition and otherwise are carried along as dead weight results in efficient operation throughout all flight regimes. Conversions can be made without difficulty even during maneuvers such as rolls, turns, and pull-ups. During evaluation tests, 6 different pilots have made about 75 full conversions in the XV-3 under every conceivable condition. Unusually low vibration levels were measured in steady and maneuvering flight up to the maximum speed obtained in a dive of 160 knots. Reconverting to helicopter flight, the smoothness of this maneuver and the excellent low-speed characteristics are evident. Several reconversions to helicopter auto-rotation with power cut to simulate complete engine failure in airplane flight have been successfully accomplished. Flying qualities in this condition are very similar to conventional helicopters. Precision control at low air speeds is provided by the direct-acting cyclic control system, and lightly loaded prop rotors make possible safe landings in unimproved areas. Air Force tests were completed in the record time of 38 working days, with 100% availability of the aircraft for the 38 scheduled tests. The aircraft was then transferred to the Ames Research Center of the NACA for further, more detailed flight testing. Here, aircraft response to control step inputs from hovering flight are being recorded to determine stability, control power, and damping about all three axes. The proven reliability of the XV3 design has made possible its successful operation and maintenance by NASA personnel during this program without contractor assistance. Rolling takeoffs and landings are being tested to determine control and response requirements for overload STOL operation. Conversions in airplane flight have been evaluated by several NASA pilots. This approach, while reconverting during a turn into the landing pattern, demonstrates the operational flexibility of this proven configuration. The Bell XV3 is the first of a new breed of practical, useful aircraft which successfully combine the helicopter's vertical takeoff with the airplane's high-speed, long-range performance.